Hello friends, I am Rohit Rastogi and I am going today to discuss evolution of digital logic and design. Let me tell you that this is such a emerging topic of today that all of us are curious to know that from where the digital logic design started and from where the IC and chip industries began. If I remember the fine day of 1945, when the Second World War was started and there was a scarcity of resources throughout the world, then the US government told to their scientists, mathematicians and all other intellectuals to optimize the resources, and they told them that to minimize the resources and get the maximum output. In 1950, the evolution of the ICs started and the first semiconductor diodes, transistors and resistors were designed. In 1954, there was a very famous mathematician whose name was Professor Gordon Moore, and he was the president of Semiconductor Child Corporation, and he gave a very famous law which was a miracle in the field of technology, and that law was famous as Moore's law. Moore's law says that in every year the size of the chip, the size of the IC will be halved and its capacity will be doubled. It is such an amazing fact that up to 35 years this particular law holds true, and by 2004 it was up to date. But in the recent technology, with the help of nanoelectronics, nanotechnology, this law failed, and then we are having very fast advancement in the technology. Moore says that in 12 months of time period or 18 months of time period, the complexity of the ICs will be halved and the speed of working that IC will be doubled. So if we see it by a graph, we can see that there is a graph which is showing a trade-off between complexity versus the size of the IC, and it says that in the starting period the complexity will be very high and size will be low. Gradually the size will be increasing and the complexity will be also decreasing, and after certain time period the size will be increasing and complexity will be also increasing. Let me tell you the era of 1975, when first transistor was used, and with the help of NP and NPNP transistors and diodes, the logic gates were designed. All the logic gates that we know are AND, OR, NOT, NAND, NOR, XOR and XNOR. Out of all these 7 gates, these NAND and NOR are called as universal gates, and the combination of AND or NOT is also called as universal gate. In 1976, the first microprocessor of 4-bit 4040 was invented, and that was a IC which was using 4-bit at a time. Then 8080 came and it became very popular, and it was a microprocessor of 8-bit which was executing 8-bit parallelly at a time. And then 8186, 8286, 80386, 80486, they came into picture. Then the first Pentium series came, and then I generation of processors came. Between the Pentium series and I generation of processors, the core to do and dual core processors also were in picture. I remember that I attended a workshop in NCR, and in that Professor Sartaj Sahni of Stanford University gave a very important statement that the present technology progress is going to work on the 1000 cores of system. Means the data will be stored and executed at least in 1000 cores at a time. So the data processing speed very fast, and we can see the miracles in coming future in the field of quantum computing and green computing, as well as mist computing and big data. So this is overall evolution of the digital logic design. And in the field of IC industry, currently the texasinstrument.com, TI.com, is a very famous website in which one can see the standards which are applied for the ICs. Let me tell you friends that in IC there are different packages in designing of the gates which are called as J package, P package, K package or N packages. Also ICs are having TTL series which are of 7-4 series, and it is having transistor logic in their implementation. 555 series of ICs are used for timer. And the ICs are of two types. There are military ICs and the commercial ICs. Commercial ICs we are using in our day-to-day life, in our study, in our labs, and different student curriculums, and which are of having very less cost, around 50 to 100 rupees. And they are working in the temperature of 0 degrees Celsius to 80 degrees Celsius. But commercial and military ICs are those in which the different high-level scientific instruments and gadgets are using those ICs, and they are used in the temperature of minus 150 degrees Celsius to 300 degrees Celsius. Like if you see, the soldiers are using different weapons, scientific weapons, different gadgets, and those instruments which are used at the volcanic eruption location, or any flood zone, or any high-end temperature, or in Antarctica continent where the temperature is very low, then the military ICs are used. So ICs are of having two types, military IC and commercial ICs. So friends, one need to know how the digital logic design evolved, and presently we are getting the boon of it in the different technological instruments. ICs are of three types: SSIC, MSIC, VLIC. SSIC stands for small scale integrated chip, which is having number of gates from 0 to 10. MSIC stands for medium scale integrated chips, which consist of 10 to 100 number of gates. And VLSI is very large scale integrated chips which contains more than 10,000 gates. Presently we are having so much advancement in the instruments and in nanotechnology. With the help of science, we are using very complex instruments which are having lakhs and lakhs number of gates, and they are called as ULSI, ultra large scale integrated ICs. Let me tell you some examples of SSI, small scale integrated chip, like we use different combinational circuits and sequential circuits. So different circuits we are going to see now: combinational circuit and sequential circuit. Sequential circuits are again of two types: synchronous sequential circuits and asynchronous sequential circuits. Combinational circuits are those which are having some m number of inputs and giving you n number of outputs. M may not be equal to n. And synchronous and asynchronous circuits are using the combinational circuits with feedback. So this is all about the evolution of the digital logic design, and in our next video we will see what are the different types of combinational circuits and sequential circuits. You may find the link in the next video where you can relate the different topics to each other. Thank you very much. Have a nice day.